In this video, we're going to complete the second half of the roof. If you're not using the senior Revit truss families, or you're simply not interested in this part, you can jump to the next video, where I'll show you this really cool method to create roof sheeting using a curtain system roof that you can save into your template and reuse very easily. Shall we?
To continue with the second half of the roof, I'm going to mirror the girder truss using this central truss right here. Remember that you can adjust the distance from the truss to the edge of the wall, so you don't need to manually adjust the height of the truncated truss afterwards. If we check the 3D view, we can see that we're going to need another truss here to support the girder truss. So back in the plan view, I'm going to place another standard truss. At the moment, we only have one type, which is this S1 truss. I'll select it and place it around here, close to this new ridge. Now select the Align tool and line up the center of the truss with the ridge. Then let's create a new truss type. Click on the truss and then go to Edit Type, click on Duplicate, and give this new truss a different name. I'll call it GT2, since this truss is going to work as a girder truss that supports this other truss. If you are tagging the trusses in Plan View, you can also change the type mark here. Now select the Associate Global Parameter button for the roof slope and connect it to the only roof pitch parameter available, along with all the chord dimensions for the trusses as well. The difference now is going to be the truss span. Here I'm going to link this parameter to the north span reporting global parameter. Alright, now I can click OK through everything, and you'll see the truss automatically adjusting to this new span. Then I can select the truss and move it 1,800 millimeters, since the truss spacing is 900 millimeters. But as you can see, it ends up very close to the center of this wall. So instead of using 1,800 millimeters, I'll just align it directly to the center. Checking the 3D view to make sure everything is fine, it looks like there's no issue at all, except that we need to add a cut on this side of the truss. Remember that if you go to the plan view and hover over the truss, you can see this arrow indicating the initial or left point. For this truss, this is the left side, meaning the cut side will be the right side. So I'm going back to the 3D view and selecting the truss. Under the construction group, I'll deactivate the right eaves. Then I'm going to do the same thing for the girder truss. First, I'll bring this section view closer so it's easier to work with. Here we can select the truss and first deactivate the right eaves. However, in this case, that alone is not enough. So I'm also going to add a cut on this same side. You can notice that the cut is controlled by this arrow, so I can simply drag this point to the edge of the other truss. Then, in the plan view, I can copy the truss 900 millimeters to create the next truss. But this new truss will need the right eaves again, so I'll turn them back on for this one. Let's check the 3D view and everything looks fine. For this last truss, I'm just going to adjust this section because we don't need the full eaves, so I'll simply measure the eaves distance in this space and adjust it in the family parameters. Then, for this area, we're going to use a gable end truss. For this, I have two different types of gable end trusses. I'll start by showing type 1, so let me go to the plan view and place it into the model. The location point for this truss should be the intersection between the roof ridge and the center of the wall where the gable end truss will sit. To make sure the truss stays centered on the wall, I can align it and lock it so it doesn't move accidentally later on. In the same way we adjusted the truncated trusses in plan view, here we can also adjust these arrows to connect the outriggers to the adjacent truss on one side and control the overhang length on the opposite side. Then let's go back to the 3D view to see how everything is looking, and we can continue modifying its parameters through the global parameters. Here you can adjust the outrigger width while the depth will match the top chord depth. Let's click OK. And now you can see how the family fills this entire space perfectly. And it's incredibly easy to configure. This family keeps the top chord continuous throughout the entire truss while splitting the outriggers on each side. To show you the second option, I'll copy this truss over here. And then I'm going to place this other family type exactly the same way I created the first one. I'm going to isolate this one to show you the difference. In this version, the outriggers are continuous while the top chord runs underneath them. Let's look at both of them together so you can understand the difference a bit better. Now, to show you the remaining truss types, I'm going to complete this whole section using the trusses that we already used before. So just to avoid making this video too long, I'll skip that process. If you purchase these families, you'll also get this model with the entire completed roof, so you can explore and study everything in more detail. All right, so in this section, I've added a hip truss here, a few jack trusses, and some more truncated trusses on this side. If we look at the 3D view, this area creates a valley. So that's the next truss type I'm going to use. Bring the truss into the model and place it aligned with the center of the ridge. I'll place it here, and then I'm going to move it slightly so I can use the align tool and lock it to the reference plane. This truss behaves similarly to the girder truss. If we look at it in the 3D view, we can see that it's not sitting on top of the trusses, but instead crossing through their top chords. But here comes the magic again. You don't need to figure out how to manually fix that. You only need to go to the plan view, select the truss, and find this marker showing us where the wall is supposed to be. In this case, the wall is in this direction, so everything is correct. Now you'll notice these two control arrows on both sides. This one should extend all the way to the intersection of the valley lines. And the opposite control arrow should extend to the outside face of the wall, supporting the trusses perpendicular to the valley truss, which in this case is this wall. And since we already have a reference plane at that exact location, we can simply use that reference plane. And so I'm going to temporarily hide this beam so I can drag the control line to the reference plane, lock it, and then finally drag the opposite control to the ridge. This way, if we check the 3D view, we can see that the truss now fits perfectly as well. So I'll create another one since we have space for two of these. At the top, we don't actually need a valley truss, but instead a valley member. I'm going to select it from the list and place it at the top. It uses exactly the same parameters and indicators as the trusses, so you can configure it the same way. The difference in the 3D view is that this isn't a full truss, but just a single member. And if this happens to you, like in this case where the member doesn't properly sit on the trusses, you can always use a simple timber beam to create this nogging. Not a big issue. Now, the last truss I'm going to show you is the mono valley truss. And for that, I've just added these standard trusses and gable end trusses into this new roof section, as you can see. To explain what's happening, I'm going to place a reference plane right here from the intersection of these two lines. If this were a full valley, this would actually be the ridge. However, this section is a mono valley, which means the valley only exists on one side. So I'm going to bring in the mono valley truss and place it on the reference plane. I can use the align tool so I can lock it properly and then finally give it the correct spacing of 900 millimeters that we've been using throughout the project. If we go to the 3D view, we can see that, as usual, the truss looks completely messy because we haven't assigned any information or parameters yet. So let's go back to the plan view and select the truss. You can see the same symbols and control arrows used by the valley truss and the valley member. Also remember that the wall distance should be measured from the truss to the wall, supporting the trusses perpendicular to the valley truss, which in this case is the mono valley truss. So on this side, this is the wall supporting these standard trusses, and actually we can also use this reference plane here as well. So let's drag the control arrow to this point. On the opposite side, drag the control arrow to the ridge intersection. If we check the 3D view now, we can see that there is still something looking a bit odd. That's because this is a mono truss, meaning it is not symmetrical. So we need to adjust one additional parameter. So back in the plan view, select the truss and find this new control arrow, then drag it over to the girder truss, which would be this one here. Notice that here we can't simply mirror this hip truss because it would clash with the other trusses. So for this case, I'll use another family called roof rafter. Remember that hip trusses are located at the wall corners, so this family also requires that exact point. So I'm going to use detail lines to find the intersection between this hip line and the wall. Then I'll bring in the roof rafter family, place it close to the insertion point, and press the space bar so we can align it with the hip direction. Click in the correct position once it's aligned properly, and finally delete the detail line since we no longer need it. Rename the family, set up the parameters, click OK, and finally adjust the control arrows so they reach the top of the ridge. Now let's move to the 3D view, and you'll notice that the slope is not actually matching the roof slope. That's because, as I mentioned in one of the previous videos, the roof slope is not the same as the slope of the hips. But don't worry about it. You simply need to select the family, go into the parameters, and activate the hip rafter parameter. This parameter tells the family to use the hip slope instead of the roof slope. Now, on the opposite side, this beam doesn't necessarily need to extend all the way to the wall. Actually, as you can see, we need to stop it a bit earlier. So back in the plan view, take the control arrow on the opposite side and adjust it as well. You can tweak this length however you need, depending on your roof configuration. For now, I'll just leave it like this. And basically, this is everything you need to create a complete and realistic timber roof framing model. Finally, let me show you what happens if the architectural model changes and they decide to modify the roof slope. Look how now trusses don't match the roof slope. You can see this gap between them. Luckily for us, this is very easy to fix. In this case, because all the trusses are linked to a single global parameter, we can simply change that parameter and all the trusses update automatically. So there's no need to waste time reconfiguring every single truss again. If you want, you can also add filters to apply different colors to each truss type or truss name.
In the next video, you'll learn how to create this roof sheeting using a curtain roof system. So, I'll see you in the next video.